Hello, everyone. This video is going to be an overview and start for MIPS functions. So simply put, functions use our jumping instructions that I've covered in another video. And it's very important that you apply proper convention to functions. So by convention in MIPS, the argument registers are used for your inputs and your output registers are your V's. So to get started here, this is a very simple example for addition. So we have our main and we have our add numbers function. Notice that I have it labeled. So I have the function labeled, I have the inputs labeled, I have the output labeled. If you're, especially if you're doing any sort of class on this program with MIPS in assembly, it's very important that you label and comment things out because you want to be able to show your professor your work. And definitely especially with assembly, it's very low level. If you work on an assignment for a couple days and then, I don't know, you on a quick vacation for a day or so and you come back and if you don't have anything commented, then you're gonna have a very hard time re-catching up with yourself on what you did. So always comment. So starting off with addition here, we're loading in A0 and A1 as our arguments to be 10 and 20, because again, A0 is our first input, A1 is our second input. Then we're jumping and linking to add numbers. Remember, with the linking part, it stores where you jumped from. So we eventually want to go back to this. So we jump to add numbers and very simple addition instruction here. We have our output VO and we store the result of A0 plus A1. And then we jump to our return address register, which is back here. I'm moving our V0 into a temporary variable because I have to use V0 for the syscall. So you have to make sure you're not overriding things. If you don't have the statement here, you're just going to override it and you're going to return 1 all the time because that's what the print integer syscall is. So anyways, we print out the result of the function and then we exit the program. So let's assemble and run this just to test it out. So this checks out. 10 plus 20 equals 30. Let's say we want to change this to 30 and it still checks out. 30 plus 20 equals 50. So let's move on to our next program here. This program is going to be a little more complicated. Simply put, we're looking to find the minimum of 2 numbers. So that's what this function is. Again, I'm labeling my function, I'm labeling the inputs, and I'm labeling the output. You will never get a full credit on an assignment if you do not label your functions. So make sure to do that, also for your own sake as well. But let's go through this. So the first before I do that though, I think it's important to note how I have my tab. I'm tabbing things, I'm indenting things. Notice how this min function, you need another label. So if you have it down like this, it's gonna be really hard to read. So I like to call this a sub function. So um, there can be many sub functions in one function as long as you are labeling your things right. So anyways, getting on to the program. Again, we're loading our arguments A0, A1 to be 15 and 7, for example. We're jumping and linking to the min. So we're branching if A0 is less than or equal to A1. So we're going to branch here and move A0 into V0 because that would be our minimum number. And then we return. Otherwise, we go through this instruction and then we move A1 to V0. So you can kind of think of this as an if else. So the if is the return A0, and the else is just our default. So if A0 is not the minimum number, A1 must be. So then we return, we jump, not link, but we jump to the return address register regardless here. Again, I'm moving V0 to T0, so our result is not overridden. We print our result and we exit the program. So let us assemble and run it. As you can see here, the minimum of 15 and 7 is obviously 7. But if I make this 70 and I run it again, 15 is going to be our minimum number. So moving on to this example. So this example has two subfunctions, right? We have our loop, which we'll need for repeated, not that shouldn't say division, it should say addition, repeated addition, and then we have our end loop. So as I just said, this function performs multiplication, and instead of bit shifting, let's do something a little different. So in this case, I decided to utilize the loop concept covered in previous videos, and addition, which is also covered in previous video, to perform the calculation. So let's get started with the program here. Our main, we're loading 2 into A0, 4 into A1, so we're multiplying 2 times 4. Jump and link to multiply. So we're initializing our V0, which is going to be our result, to 0. And then we're initializing a counter to 0. So our loop here, if the index is greater than our second factor, then we stop because we had our product. So we branch to end loop and then return. Well, not branch, but jump to our end loop and then we return. Otherwise, we add on to the result V0, and then we increment the counter. Once we return, again, making sure our registers are not overridden when we don't want them to be, we print the result and exit the program. So let's assemble this, test it out. As you can see here, 2 times 4 equals 8. Can try, let's do 5 instead of 2. Yep, still works. 5 times 4 equals 20. So I hope this video was a good overview of functions. These are 3 pretty simple applications, but it's important to be good with these concepts because if you're not using proper conventions and you're not indenting right, then your program is going to be really hard to read if you're getting past the 100-line mark. So anyways, thank you for watching. I hope this video was informative. Please comment if you have any questions. Thank you.